Hello everyone, welcome back to my YouTube channel. In today's video, I'll be teaching you more on stoichiometry. Stoichiometry just means more concepts. It has to do with calculations in chemistry. In my previous video, I explained more on more concepts. So please don't want to go back to my previous video to learn more on more concepts. In today's video, I'll be looking at some examples on stoichiometry. And the first example goes thus. In a titration experiment, 20 centimeter cube of aqueous sodium hydroxide reacts exactly with 25 centimeter cube of 0.1 mole per decimeter cube dilute sulfuric acid to make sodium sulfate. The equation is shown here on the screen. The question goes thus: calculate the concentration of aqueous sodium hydroxide in gram per decimeter cube. So for stoichiometry, you'll be comparing two things. Is either you compare two reactants or a product with a reactant or two products. Whatever case it is, it will be indicated in the question that you have. So in this question here, we are meant to compare sodium hydroxide. We're given information on sodium hydroxide. So that means that we're comparing sodium hydroxide and dilute sulfuric acid. And how did we know that? Because we're given more data on sodium hydroxide, as if we're given the volume of the sodium hydroxide, and we're also given the volume of dilute sulfuric acid with its concentration. So that is the reason why we are comparing sodium hydroxide with dilute sulfuric acid. So that means that from our question here, we can say that we are comparing the two reactants, that's sodium hydroxide and dilute sulfuric acid. So to start with, we need to write out the information or the data that we're given on each of them. So we're given 20 centimeter cube of sodium hydroxide. And for sulfuric acid, we're given the volume, that's 25 centimeter cube, with the concentration, that is 0.1 mole per dm cube of the sulfuric acid. So we're given the volume and the concentration of the sulfuric acid. From here, we can get the number of mole of the sulfuric acid that is used. Remember from my past video, I told you I gave you about 3 equations or 3 formulas for calculating number of moles. So for this equation here, we're going to be using this formula. Number of mole is equals to concentration in mole per dm cube multiplied by the volume in decimeter cube. So now take note. The volume that we're given here is in centimeter cube. So we need to convert that to decimeter cube. And how do we do that? We just divide the volume that we're given in centimeter cube. We divide it by 1000. So our concentration here is 0.1 multiplied by the volume that we're given, that's 25, divided by 1000. That's to convert it to decimeter cube. And our answer is the 0.0025 mole. So that is the number of moles of sulfuric acid that we're given, or that reacted, that we're given. Yes. So now the next step is to get, the number of moles of the sodium hydroxide that was used. How do we go about that? It's very easy. From our equation that we have, from the chemical equation on the screen, we take the mole ratio. So sodium hydroxide, the mole ratio of sodium hydroxide with sulfuric acid, according to the equation that we have on the screen there, is ratio 2:1. But from our calculation here, we can see that we can see the number of moles of sulfuric acid that was used as 0.0025 moles. So we use that to get the number of moles of this sodium hydroxide that was used. So how do we do that? We need to cross multiply this. So cross multiplying that will give us the number of moles of the sodium hydroxide that was used. So that will be 2 multiplied by 0.0025. And that is going to be giving us 0.005 mole. So that is the number of moles of sodium hydroxide that was used. But then the question is, calculate the concentration of aqueous sodium hydroxide in gram per dm cube. For us to do that, we need to get the concentration of sodium hydroxide first in mole per dm cube. Remember that we still have one more information here that we've not used for sodium hydroxide, and that is the volume that we're given. We're given the volume here, which we have not made use of. So we're not going to use that here to get the concentration. So concentration, formula for calculating concentration in mole per dm cube. Concentration is equals to number of moles divided by the volume in decimeter cube. The number of mole that we have is this. So we have 0.0, so we're given 0.005 for that. Divided by the volume. But remember, we still need to divide that by 1000 in order to convert that to decimeter cube. So our concentration of sodium hydroxide in mole per dm cube is 0.25 mole per dm cube. We're not done yet because the question says that we should calculate the concentration of sodium hydroxide in gram per dm cube. So what is the relationship between concentration in mole per dm cube and gram per dm cube? So it goes thus. Concentration in gram per dm cube or gram per decimeter cube is equals to concentration in mole per decimeter cube multiplied by the molecular mass. That's the MR. Now, molecular mass of sodium hydroxide, if we calculate it, that will be 40. You can get that in the previous video, how to calculate the molecular mass. So now, since we've gotten that, so concentration in gram per dm cube, in gram per decimeter cube, will be equal to the concentration in mole per dm cube, that's 0.25 multiplied by 40. And that will be equal to, and that gave us 10 gram per decimeter cube. So that is how we go about calculating some questions in stoichiometry. A second example goes thus. When sodium hydrogen carbonate is heated, it forms three products as shown in the equation below. You can see that when sodium hydrogen carbonate is heated, it gives three products, that's sodium carbonate, water, and carbon dioxide. Now the question is, calculate the volume of carbon dioxide formed at room temperature and pressure when 12.6 grams of sodium hydrogen carbonate is heated. Now we are to look for what? We're to look for the volume of carbon dioxide, and we're given data on sodium hydrogen carbonate. That is, we're given the mass of sodium hydrogen carbonate. So as usual, that means that we're comparing the sodium hydrogen carbonate with the carbon dioxide. And what are we to do? We're to look for the volume of the carbon dioxide. So we're comparing these two. So we bring out those two things that we need to calculate, that we're comparing rather, and that is the sodium hydrogen carbonate with what? With carbon dioxide. From the equation here, the ratio is ratio 2 to 1. But we're given information on the sodium hydrogen carbonate, and that is the 12.6 grams. So for us to go on with that, we convert this 12.6 gram to moles. So comparing that to mole, remember, number of mole, one of the formulas for calculating number of mole is equals to mass divided by the molecular mass. The molecular mass of sodium hydrogen carbonate is this. Is 84. That is the molecular mass of sodium hydrogen carbonate. So we're going to slot that back to get the number of moles that 12.6 gram will give us. we're given the mass, which is 12.6, divided by the molecular mass, and that is 84. And that will give us this. That gave us 0.15 mole. Now, having gotten the number of moles that we have in 12.6 gram of sodium hydrogen carbonate, we go over to slot that into our mole ratio that we have there. So I'm going to write that here again for clarity. So remember, we're comparing sodium hydrogen carbonate with carbon dioxide. From the equation that we have here, we have 2 moles of sodium hydrogen carbonate, supposed to give us 1 mole of carbon dioxide. From our calculation, we're given 0.15 mole of sodium hydrogen carbonate. We need to use that to get the number of moles of carbon dioxide. So we're going to cross multiply that. So cross multiplying that will mean that to get that, so X will now be equal to 0.15 divided by 2. And that will be giving us 0.075 mole. So that's the number of moles of carbon dioxide that we're given. Now, how do we convert that to volume? It's very easy. One of the formulas for calculating number of moles is equals to the volume that you're given divided by the molar volume. At room temperature and pressure, because we're looking at RTP. Remember that the molar volume is equals to 24 decimeter cube. That is the molar volume at RTP. So we're going to slot that into this. So that will be volume divided by 24. Now we're looking for the volume. We already have the number of moles. So making the volume the subject of the formula will give us this. So that will be equals to the number of moles, that is 0.075 multiplied by the molar volume, 24. And that will give us this. And that is our final answer for this question. So the volume of carbon dioxide will be given at room temperature when 12.6 gram of sodium hydrogen carbonate is heated is equals to 1.8 decimeter cube. I hope that is clear enough. The last example that we'll be looking at in today's video goes thus. Determine the volume of carbon dioxide gas given when excess magnesium carbonate is added to 25 centimeter cube of 0.4 mole per decimeter cube of hydrochloric acid at room temperature and pressure. As usual, we're meant to calculate the volume of carbon dioxide. So that means we have that when excess magnesium carbonate is added to 25 centimeter cube of 0.4 mole per dm cube of hydrogen chloride or hydrochloric acid. So that means that in this equation here or question, we are going to compare the hydrochloric acid with that of carbon dioxide. So that is what we're comparing in this question here. So to begin with, we write out the information or the data that we're given. So for this question, we're given data on the hydrochloric acid. And the data we're given is that we're given the volume, which is 25 centimeter cube, and we're given the concentration, and that is 0.4 mole per decimeter cube. All of what's on hydrochloric acid. So from this information that we have here, we can get the number of mole. Remember that number of mole is equals to what? Concentration multiplied by volume, but the volume has to be in decimeter cube. So we go on to calculate that. The concentration that we're given is 0.4, and we're given the volume to be 25 centimeter cube. Converting that to decimeter cube means that we'll divide that by 1000, and that will give us this answer here. Having calculated the number of moles of hydrochloric acid that we have in this question, we proceed to compare the two substances that we need, and that is the hydrochloric acid with the carbon dioxide. From the equation that we have here, the stoichiometric equation we have there, 2 moles of hydrochloric acid will give us 1 mole of carbon dioxide. So we put the mole ratio there, that's 2:1. But we've gotten information, we've gotten the number of moles of hydrochloric acid that was used. So that is 0.01. We use that to get the number of moles of carbon dioxide that will be given off. So calculating that will give us this. So number of moles of carbon dioxide that will be given off will be equal to 0.01 divided by 2. And that will give us 0.05 mole. Since we have gotten the number of moles of carbon dioxide that is being given off, and we are asked to calculate the volume of carbon dioxide gas given, all we have to do is to convert this number of moles to volume. Remember, the relationship between number of moles and volume goes thus: volume divided by molar volume. The molar volume at room temperature is still 24 decimeter cubes. So we're going to slot that into that. So that's 24 decimeter cube. So now converting that will give us this. So that will give us 0.12 decimeter cube. And that's the volume of carbon dioxide gas given off when magnesium carbonate is added. So that'll bring us to the end of today's teaching. I hope you enjoyed it, and you can see that calculations that has to do with stoichiometry is quite easy. It's not as difficult as you think it is. So before we end this lesson, I'll be dropping this question with you to practice with. I'll be waiting at the comment section for your answer. And remember, there's a prize for this question. Here's the question that I want you to practice and drop your answer in the comment section. Thank you very much for watching and joining me and watching into this video. I hope you enjoyed today's teaching. Please do remember to subscribe, like, and share this video with your loved ones. See you in the next video. Bye for now.